This talk is really for people that are supposed to already know the Gradle API to create Gradle plugins. I gave a talk at DevOps France about how to onboard the Gradle plugin. There will be a slide at the end of these slides leading to this content. Feel free just to read also the other slides because you will learn something interesting if you never tried to build a Gradle plugin. And that will be useful for you. Let's start. So I'm Eyal. I work at Genymobile on a project called Genymotion. There is a link to these slides right now. So that's bit.ly Gradle-plugin-next-level. You can get it for the people at the end of the room. Please open it because you won't see the slides, just to let you know. Okay, and there is a Eyal.fr if you want to find my social networks link. So, let's start. What we will tell about today, first we will come back to the basics. So when you are building a Gradle plugin, there are some notions you are supposed to know. So we will just come back quickly to this. Then we will see how together we can build better DSL, and we will explain also what is the DSL, and to make it more Gradly. And we will tell also how your plugin can interact with the Android Gradle plugin. Then how to test your Gradle plugin, because that's really efficient, really nice to test your Gradle plugin. That's really made for that, actually. And I don't think we will have the time, but there is a few slides about how to publish it and become famous using your Gradle plugin. But I think we will skip it. You will be able to read it later. Okay, let's start. So, first, let's take some definitions. What are the different Gradle plugins type? First, maybe you don't know, but build.gradle files are plugin. Implementally, I don't know if we can tell that in English, but yeah, how it is implemented, build Gradle are considered like plugins for the Gradle core. Also, there are script plugins. Script plugins are build.gradle up. There are build.gradle where you modify the script and you integrate plugins, and you use the Gradle plugin API. And what we will tell about today is more the binary plugins. Binary plugins are jars that you can build, or a Maven repository, where you can put your Gradle plugin so people can use it. Then another thing, Gradle Task. So a Gradle Task is a piece of work when you launch, I don't know, assemble debug when you are developing an Android, or a connected Android test. That's a task. These tasks can be manipulated. Everybody, even you as a user, or even me as a Gradle plugin developer, we can manipulate that and inject code inside using do first and do last. Maybe you already done it. They can inherit also each other. For example, the copy task is really used when you want to copy a file. So that's really atomic. You can use it and just configure the task you want to build. And also, and that's an important point, Gradle tasks are linked each other. And when you are launching a task like connected Android test, what it will do a lot of things, and part of them are compiling Java 2 classes, then put that on to build a full APK, then to launch it on devices that are connected, then launch the test, etc. All of these steps are tasks, and you can use depends on and finalized by, that's the API, to link all tasks together. So basically, as I told you, one task you launch, execute a task graph. Okay, another thing, what is inside the binary plugin? First, the binary plugin is a Gradle project. And actually, that's most of the time, that's a Groovy project. It contains a build.gradle, because that's a Gradle project. it contains also a plugin class. That's the entry point of your plugin. There's also a descriptor that's kind of, that's not really, that's just for packaging meaning, so the builder knows what is the plugin that you have to launch when you use your plugin. You have also to put several tasks in it. And something very interesting and something very important, there is an extension. The extension allows the user to interact and to configure your plugin. For example, when you use the Android plugin, you are opening, so you apply the Android, the Google's Android plugin, and you open an Android block, and then you add, I don't know, flavors, default config, etc. So this is the Android plugin extension. Some example of plugin you already know, the Java, Groovy, Maven, Android plugin, etc. There are a lot. Then the global lifecycle. First, we can consider there are three main steps. The first is initialization. During the initialization, Gradle will take care of all the projects of your project and see the interaction between them. Then there is the configuration, and inside the configuration, there is the evaluation step. And during this evaluation step, all the build.gradle files that you have in a project are executed. That's where the configuration you made into your build.gradle are read by Gradle and injected into all the objects you created, and part of them are the plugins that you applied. And also during the configuration step, and following all these configurations that are read, the task graph is built. And when the task graph is built, the execution is done. There are a lot of events that you can trigger, and when you can interact with the project, how it evolves. Here is some of them. For example, before evaluate, after evaluate. After evaluate is quite interesting because it's called when all the build.gradle are called. So you can be sure that your extensions are now already read by the project, and the configuration of your user are already set up. And that's a very good entry point, for example, when you want to inject task into the Gradle task graph to put your code in. Okay, so we finished with the basics, and we will focus more on the DSL. What is a DSL? It means a domain-specific language. So that's a language. That's a language a Gradle plugin developer build. So basically, that's a language you have to build as an Android, Gradle plugin developer. And there are some principles that I wanted to share with you that I find quite important when you are building a DSL. First, it has to be readable, and we will see how we make it more readable. Then it has to be flexible. Why flexible? Because sometimes you declare some weird situation. Your user have to declare. I can give you an example. When you are developing, who is developing an Android app here? Who is an Android developer? So you all know that. You already created build flavors, right? So how build flavors work? You open Android, then project flavors. Yeah, that was project flavors. And then you declare the name of your project flavors, whatever it is. So as a DSL, as a language interpretation, you cannot guess what will be the name you will enter. So that's a kind of flexibility you can bring into your project. It have also to be intuitive. So you will see how we can work on that. And also it have to be talkative. So a DSL, technically it can be talkative because that's the user is writing. And the DSL is not supposed to express himself because that's the user which is supposed to express himself. But as there is no auto-completion on the build.gradle. The documentation is always hard for a developer to maintain. A lot of time your user will do mistakes. And the idea is that when you launch task, you know that you've done mistakes, and you respond to this error with interesting messages. So for me, it's part of the DSL because it's not part of the language that the user will use, but it will be part of the dialogue between the user and your plugin. How to make it readable? So for everybody that already built a Gradle plugin, sorry for the people that never done, I'm sorry. You can use this API. So that is supposed to call into your apply method. We will see that later. You use project, then extension, then create. You call the name of your extension, then you give the type of the extension, and then it's instantiated by Gradle like magic. On the extension side, here is a very dummy extension. So there is a string and a list of string. You declare usually default values into the constructor of this POJO, because that's really a simple POJO or POGO if you do it in Groovy. Yeah, all the examples, all the code that I give will be in Groovy. For the people that never touch Groovy, let's say that's really simple. That's like Java, but without column, really. Yeah, column, yes, that's that. There are a lot of things that can be used and are really convenient in Groovy for building plugins. We'll see that later. Also, on the user side, he will apply your plugin, then he will be able to use your extension. You see my extension, that was the name I gave to the extension before, and he will be able to configure each extension. So there is default values. For example, on the string, it was default string. But when he opened this block and called my info, it will change my info, that is the string, to new string, because that's the value he defined it. The same for the list. Okay, you get the point, everybody? That's great. So now a part of the talk, a big part of the talk will be a feedback from our experience at Genymobile to build the Genymotion Gradle plugin. So what we can do by knowing that into our plugin, what we can do. For example, we can create a Genymotion extension and add these values, config license server true, etc., config license server address. We can do something like this, okay? And then what you can do also is to let the user call functions, because that's a POJO. So basically, you can call functions, methods, from the build.gradle. We will focus on the functions later. But now, when I read it, I don't know you, but for sure the people at the end of the room cannot read that, right? Me neither, but I'm in front of my screen. Because that's not very clear. What I would like to do is this. Extract the config notion into a block, and then nest a config block into my Genymotion block. How can you do it? Just using nested extensions. That's really easy. The idea is that you call project, then Genymotion, dot extensions, dot create. That's exactly the same API than the project. So you can nest extensions. And I declare a config name, and then Genymotion config, that's the type that will be instantiated. So that's the type of my POJO for my extension. And that's all. That's quite easy. That was one point. Let's go a little bit further. How to make it flexible. So now we'll focus more on the call I showed you before. Oh, just to let you know, for the people that don't know about what is the, because I think that that will help you to understand what we want to do actually with this plugin. What the plugin, the Genymotion plugin allows you to do is to configure and to declare devices that Genymotion devices that you want to see running before your test. So, for example, you will declare here a Nexus 5 running using this template, Google Nexus 5 using Lollipop. Then you will define also another device, Nexus 4, etc. You get the point. So that's the idea of the plugin. I think it will help you to understand that the content. So that's basically what we have for now. We have these methods we can call, but that's ugly. I don't know you, but I really find it ugly. So what I can, and that's starting to be ugly, but when you want to add parameters, because for now I just declare the name of the device and also the template, so what Android version and the screen size I want to have into the device, but maybe I want to change from the template to another size and change also the pixel density. And maybe I want to do more. I want to install APKs into device before the run. I want to extract at the end of the run some files right here. I don't know what is value for, but let's see. So we can have an infinite number of parameters into this method. So when we thought about this plugin, we started to do one thing. It's to use the groovy named parameters. So using the name parameters, what basically it is, you know, you have parameters with names. The user can just put the name, then colon, then the number. So naming parameters, that's really simple. So when in the documentation, we wanted to name all the parameters so they know what they are sending to the plugin. And that was the result. So for example, the name is Nexus 5, the template you get it, the width, height, density, etc. So that's a little bit better, but really I find it ugly still now. And there are some problems because of course it's very verbose, and you also have to, don't forget this comma at the end. That's not so good. What we wanted to do is something more like this. To be able to declare devices, to name them, and then to configure them as much as we want using blocks, because that's more clear, that's more easy. And they are not supposed to send all these parameters. They can just choose. So yes, sorry. The user will create devices block, and what is happening there is actually the Genymotion extension is called by the devices method. So the devices method inside the Genymotion extension is called, and what is passed as a parameter is a closure. A closure is a piece of code that will be executed by Gradle. Just to let you know, that's like lambdas, if you already done Java 8. And that's something that is extremely convenient and used a lot concerning the Gradle DSLs. So basically, that's what happened. So you call the devices method into the Genymotion extension, and then you pass these blocks. So Nexus 5, this is one, and also Nexus 4, you get the point. But actually, Nexus 5 and Nexus 4 blocks, what they are doing conceptually, they are adding Nexus 5, one device that is called Nexus 5 and another device that is called Nexus 4 into a list of devices that have been that have to be created, then run, right? You get it? And actually, where they are added into a container. And we will see right now what it is about. So we are back into our plugin class. You remember I told you about the plugin class on one of the first slides. So this is the plugin class. And this is the apply method that is called when the user do apply column, I don't know, Genymotion or com.android.applications. So this is the method that is called. So I will pass this because that's not very useful. Then what you are doing, you create a container calling project.container. You give the device launch. Device launch is simply the type of object that will represent a Genymotion device launch, as I showed you. So Nexus 5 and Nexus 4 will be instances of device launch. And when we pass, and then we pass a factory. Then what we are doing is to create our Genymotion extension, and we give device launches variable that contains the container we created right before, and this will be passed to the Genymotion extension constructor. And as I told you before, on Genymotion, what we do is that we are injecting our task on the after evaluate listener. Okay, this is the Genymotion extension. That's a Peugeot, as I told you. That's really simple, and it contains this real typed name variable. So that's name, domain, object, container with the template device launch. Device launch is ours, and this long type, don't know it by heart. You will have the slide, but that's the best way, and that's the easiest way, and actually that's the only way to implement this kind of flexible DSL. So you get it. We get the device launch into the Genymotion extension constructor, and we just pass it into the constructor. Up. And this is the devices method that is called. Here is the closure, that is the parameter, and what we do inside this method is really simple. We take device launches and we call configure on it, passing the closure. And then you let Gradle do everything for you. That's really simple to implement this kind of DSL, and that's the way you can do. Here is the factory. The factory is a name, domain, object factory. Really, that's an API that you have to learn. So that's just an example. Take the example and start from it if you want to do it. And what the factory have to implement, because that's an interface, just the create method taking a string that is called named inside. And inside this method, you have to create your device launch and return a device launch. So that's really an API, very simple API that you have to know. But it's not documented, just to let you know. You won't find it on the Gradle documentation for right now. I didn't try it last weeks, but a few months ago that was still not documented. So that's the reason why I give you all this smelly code, because you won't find it so easily on the internet. Here is the device launch. That's also a Peugeot. And what it has is a simple constructor using the name. And actually the name, you know, is the name of the block Nexus 5 and Nexus 4 is the name passed here into this example. So you know now how to build flexible DSL. Let's make it a little bit intuitive. We go back to our example using Nexus 5 block, and it's cleaner now, but some part can be improved. And these are the parts that can be improved. The install and the pull after sections. So, sorry, let's extract it. This is not really clear because the user still have to create an array and put information inside. Here is a map that the user have to create, etc. That's a little bit verbose. So what I wanted personally do is something like this. Install, then give a list of string separated by comma. There are a lot less characters to enter, that's better. And also on pull after, because there are two notions here on pull after. You ask for a device there is a file that it is into the device, sorry, and you want to extract this file into your host, so somewhere into your computer. So what I wanted to add is to use name parameters from and to. So let's see how we can implement it. For example, install. We will create simply a method, because basically on the first example, what the Gradle is doing is that it will set the install list of string directly by its own. So there is no interpretation by ours. We don't control what is passed. We cannot handle it to, I don't know, give interesting messages. And the idea of all this part is really to not let Gradle set and let Groovy set the variables, but to handle it using your own methods. So what we are doing, we create install method, taking a string, a list of string, and we add it simply to our list of string that is called install. Also on pull after, that's exactly the same, but with a map. Here is a map, a Groovy map. And we use two parameters, from and to, and the user is free to use it or not, to use the name parameters or not, but now he can. Okay, so that was another example of how to make it more intuitive for the user. Then we will finish with the talkative part, and you know, you are all aware that as an Android developer, the whole thing is to follow the changes into the Android DSL, the Gradle Android Plugin DSL, because at early stage it changed like every week, if it's not every month or every hours. So that was really hard to follow. And there is no auto-completion. Auto-completion is really part of our job. That makes us really, really more powerful, but it is not when you are talking about Gradle build system. And that's a real problem. So as a Gradle plugin developer, we have to handle it and improve it. And the idea is to give feedback to our user. Yeah, as I told you, there is no discoverability. So what you have to do is to use logs as much as you can, following the Gradle convention. There are different levels you can use, and you can instantiate loggers very easily, and make these errors part of your documentation. Really, consider it like your documentation. It is supposed to guide your user to the thing he wants to do. Okay, we finished with the DSL. And now we have a plugin that is working well, right? The user can share with him quite easily. It's easy to document, and we consider all the problems that can be bring by our DSL, and we fix that using logs. But it's still not interacting with the Android Gradle plugin. So the idea of the I can give you the example of the Genymobile plugin. What we want to do is to inject our task into the connected Android test task run, because we want to run our devices right before the instrumentation test launch. So we have to inject our task into the task graph that is created partly by the Android plugin, right? And when you want to do this, you don't really know, but there is a documentation about that into the, you know, that's tool.android.com or something like that. There is the URL actually later, so you will have it. And so that's the main entry point, because that's the documentation that is displayed by the Google guys. So it's quite interesting. And what you learn there is there are different things. Does everybody know what is the variant here? Raise your hand if you know that. Okay, so just to let you know, variants are, so you know the build, the build type, right? Debug, release, etc. You can add your own. You know also product flavors, like your own. I don't know, x86, ARM can be flavors you decide to not embed into one APK. And variants are the combination of the build types and the product flavors, okay? So the interesting thing is that when you want to inject your task into the task graph, generally, because you know you can do many things, but generally you will use flavors and go through the collection of variants that are created by the Android plugin and inject your task into the link you can find from these variants. Okay, so that's a good thing. That's a good entry point when you want to deal with the Android plugin. And there is a documentation for that. You can list the application variant, the library variant, and the test variant. How you call them? That's quite easy. You call the Android extension, then application variant, then all method. That is, so it's opening a closure where you have the variant that is enumerated, and then you can do your stuff inside. That's what we are doing basically. An important point also, you have to call these line after the evaluation, because basically when you are calling application variant, it launches things inside the Gradle plugin that can do a big mess into your the task creation if it's done too early. And this is also part of the documentation. Okay. So now, so here is the link to the documentation. There is a dedicated section that is called manipulating task, and there are very interesting details with tables where you can find all the properties that you have into this variant. So this variant have properties. You can find many information to interact with the plugin. But the problem is that this documentation, I measured that is 30% wrong, really. And we will see an example of that. But that's a good entry point because you get the logic of the how they build it and how you can interact. So read it, that's really important. But consider that it's partly wrong. So what is the real documentation? You know, people tell it so much. The source code is 100% accurate, and that's true. And we will see how we can use it. But yeah, how you can do to get the source code, you clone the repository, and then you check out to the good tag. The current one is 1.3.1. That's the version of the Android Gradle plugin. But that's not the only documentation you can have. There is a very, very interesting documentation, is your debugger. And you can find many things, and we will see together how we can use our debugger to just debug it and get the real information where it is, because you know, the documentation is not good. And as for now, I didn't try too much, but I've seen that it's extremely hard to debug, and not maybe impossible. I never tried too much, as I told you, to debug your plugin when it is inside Android Studio, for example, on the user side. That's really, for now, I never succeed to plug a debugger into my jar file that is running on Android Studio. So an important thing also is to create integration, and that's a very good reason to create integration tests so you can develop your project, running your tests, and debugging into it because that's native. The debugger is really working extremely well because you are inside your project and you run your own project using your tests. So that's a first very good reason to use integration tests, and we will focus on the test later. Yeah, something I wanted, a little story I wanted to tell you about. Internals are changing a lot. And for example, connected Android test is the task I told you about. Maybe all the people are running integration tests are using this task, right? Yep. Who is using this task almost every day? Oh, you are not so much to do integration tests, right? That's fine. But you all know that. And basically, the first time I developed that, I used this value. And I was working with this value. And that was a big mistake. And we'll see that together. And instead of using this magic string, use dedicated properties that you will find in the variant value that you get. Like this, for example. So here is what we do, basically. Android, in the Genymobile plugin, Android, test variant, call all, you get the variant, and you extract the test task. The test task is where we want to inject our task, before and after. And there is, the documentation said that there is the variant dot connected Android test value where we can extract and get the task we want to use. Okay, that's all from the documentation. So I've done that, and then I launched my test, testing if everything was working well, and it was not working, obviously. Why? Because it was not able to find the connected Android test property inside the variant. So this was wrong, but this was from the documentation. But this was wrong. So what I did concretely, I opened my debugger right here. Oh, sorry. If I put my finger on my screen, you don't see it, right? So here's my mouse. So I put a breakpoint here, and I just browse into the variant object. And what I find quite easily, really, is that on variants, there is another property that is called variant data. And inside variant data, there is this connected test task, interesting name for us. And yes, actually, it was connected debug Android test. So that was the property I was looking for, and I found it. And the real name was variant data, then connected test. So what I've done, I took the source code and I looked for this variant data.connected test. And I found that there is, in test variant implementation, this method called get connected instrument test that was returning on a row variant data.connected test task. So on the test variant, the variant data, the good API was variant.connected instrument test instead of this, sorry, it is here, connected Android test. That was very simple, just a new name to use, another one, because the old one was not working. And that's just an example of how you can use your debugger and the source code of the Gradle plugin to get rid of the outdated documentation. Even if I really advise you to start using the documentation and just debug it. And maybe provide feedback about the mistakes so they can change it. To be honest, I gave that talk at the DrakeCon London, and I had the chance that, I don't know if it was a chance, but a part of the Google guy that is working on this plugin was at the first row, and he gave a picture when I told that there were 30% mistake into the documentation. So yeah, another example of why you have to not use magical string like connected Android test is that I will show you. I will go to the history. That's the name of the task pointed by this value. So the one we use, connected instrument test. So on the 1.0 version of the plugin, it was called connected Android test. Then 5 months later, that was the 1.2. It was called connected Android test debug. They added the build type at the end. And then 3 months later, 1.3, connected debug Android test. It just melted. So now you know, don't use magic strings. They do what they want and they develop an API that the documentation is not good, but to be honest, when you find this for our project, everything is working well from 1.0 and we are compatible with Android plugin 1.0 to even the beta version that are working. Okay. So you know now internals are changing a lot. Okay, great. We are on time. Do not depend on specific release. Your users are Android developers, and we are all free to choose the Android plugin version we want because we have constraints, there are interesting things we want to do, etc. So don't depend on a specific Android version. And for that, what you have to do is to develop integration tests between your plugin and the Android plugin and run them on different Android versions. And we'll see now how we can test that. So I will try to be quick on how to test your plugin. But just to let you know, really, that your plugin is a Groovy project. So Groovy is a very good language to make things, and it's compatible with all the testing libraries. So they are not really constrained to to test your project. But there are a few specificities. You have to stub your project, and you will also have to evaluate it. Let's see what it is about. So we don't care. This is how we add the Genunit plugin to your project. Genunit library, sorry. Now we test the extension. So this is our test class, and we are creating our stub project, calling project builder.builder.build. You get your stub. Then into this project you apply your plugin, and then you do a small assertion. This is a very simple example, right? Project Genymotion. So I'm testing that the extension is on the good type. Okay, you get it? You can do many other things, but you have the bootstrap. Now that's your job to improve it. But that's not enough, because this is just the extension. You also have to test that your task will be created and injected into the graph task on the good way, right? So let's try to see how we can do it. So we stub our project like this, and we assert that the Genymotion task is the good instance. And actually, it fails. Why? Because my Genymotion task is not created on the apply function. Do you remember? There is the apply method that is called, but I create the task here on the after evaluate listener. And this code is called after the evaluation. But if you look at the document, the Gradle plugin documentation, or even the Java reference, you won't find any evaluation or something like this method. A method that allows you to launch the evaluate. So, okay, let's do it. We call evaluate on the project. And it works. That's magic, right? Just a few stories, because you can imagine that I didn't find that like magically. That would be very weird. Yeah, you can be happy after that. Here is the message I found that let me know that this method was existing. A guy asking for, guys, why this method is not accessible to everybody. And here is the message, an answer to the guy. And you don't see this in the API doc for project, because it is an internal method, and it's supposed to change, etc. There will be a supported mechanism for doing this kind of thing in the near future. So who inspired that? A very good guy. You should see his conference, because it's really interesting. I'm really inspiring from him for many of my Gradle talks. This is Luke Daly. That's a core engineer at Gradle. It used to be Gradleware, but now it's Gradle. And that was on the Gradle forum. And do you remember? There will be a supporting mechanism for doing this kind of thing in the near future. And that was June 2011. So the future is very far for now. Okay. So now you know how we can launch and how we can really test quite fully our Gradle plugin on its own. But now let's add the Android Gradle plugin. So how you do it? Before we added Genunit on our dependencies, now you add on test compile dependencies com.android.tool.build. This is the package of the Gradle plugin. And you can add it specifying the version you want to use, right? So for this example, we will use the 1.3.1. That's the last release. We stub our project again, but we will add a small thing. We will tell the project root is supposed to be this directory, and this is the root to the directory. I will show you later. Then we add the Android plugin. We add again our plugin, of course. We want to test that. We also, you now have to declare the project.android. So there are a few parameters that the plugin is looking for. If you don't put that, it won't run, because for him it's a mistake. And that's a part of the talkative thing I told you about. This is an example, a very good example. It needs that or it failed, so it failed if you don't put that. So you also have to put that on your stub. And what you have to, so here is the hierarchy of the directory I showed you before. That's a really simple Android app. There is almost nothing in it. There is this structure on the main directory. There is an Android manifest. Fine, sorry. And sorry. And there is the local property. And what there is in the local property, there is the SDK here with the path to the SDK. And the Android manifest is really simple. That's just the manifest tag, nothing else. Really simple. So now we are all set to start developing our tests. I personally use categories to categorize all the Android plugin related tests, so we can run only them when we want. And what we are doing, for example, we are creating product flavors, then we evaluate, you see that? And then we test that our dependencies are clearly injected. I won't go deeper into the detail because that's really a part of the API. This is really accessible. You can do your own. And we are running out of time. But you get the point. Now you can read back the slide and get this. But basically what we do is that we iterate on variants and we see that our tasks are clearly injected to make this test okay or not. So you have to ensure the compatibility with all the Android Gradle plugin, and that's really feasible. For now, I didn't see the limit. Our use case is isolated, I don't know, but just to let you know, for me, it's feasible. And also, the thing is that you need for that to control the Android plugin version from outside your build.gradle, because it's not supposed to change it at the runtime. I tried it, not too long, but for now I never succeed to change the Android plugin for different tests. So what you will have to do is to run your tests on different Android Gradle plugin version, and to do that you use Gradle properties. How you can do that, for example, here is the Android version variable. It's set to plus, so we will use plus by default into our build.gradle. Then we check that the launch declare the Android plugin version property, and if it's set, we set it to Android version. So basically, we change the 1.3.1 before with this parameter. And what we can do now is, if you want, we can specify into our Gradle test call -p Android plugin version with the version we want to run. And then you can run this task to iterate on all the version you want to support. And that's all. You get it. A good idea for you when you run all this before your validation, every day you can run this task using the plus. So you test your plugin with the very last version of the Android plugin. And for that, you have to use the gcenter repository. And of course, as I told you, to use the plus. Maven Central doesn't get the last beta version, or not the last one. So use gcenter if you want the very last one. As I told you, we will skip publish it, but it explains how to extract your jar, or send it to bin tray, and be inside gcenter repository. That's finished. I hope you liked it. And I don't know if we have 1 minute for questions. No? Usually, no, that's fine.
No, we don't have any time for questions. So roll of applause for Eyal, please.
Thank you.